Alright, we are looking at Wednesday's worksheet covering definite intervals of composite functions. We did number 1 in class, so we're going to get started with number 2. Our inside function on number 2 is 9 plus x squared, so that means u needs to be 9 plus x squared. Derivative of that is going to be 2x dx. If I notice in my problem, I've got an x, I've got a dx. I do not have a 2, so that means I need to move the 2. Okay, now I'm ready to substitute. So I'm going to have 1 over the square root of u du, and then since I'm going to u, I need to change my limits from x to limits of u. So I have 0 and 4. So I plug 0 in here, 9 plus 0 gives me 9. I plug in 4, 9 plus 4 squared, which is 16, so that's 25. And then I need my 1/2 out front. So now we're ready to integrate. Remember, this right here is the same thing as u to the negative 1/2, so that means it turns into u to the positive 1/2 times the reciprocal is going to give me 2. I've already got the 1/2 there, and we're going from 9 to 25. So these two cancel. I plug in the 25, so that's 25 to the 1/2. I plug in the 9, that's 9 to the 1/2, so I get 5 minus 3, which gives me 2. So number 2 is 2. Alright, number 3. Inside function on number 3 excuse me, is x cubed plus 1. So that means du is going to be 3x squared dx. In my problem, I've got an x squared, I've got a dx, I do not have a 3. So that means the 2 needs to come out, and I need to get rid of this 3. Now I'm ready to substitute. So that means I'm going to have a 3 out here, because I had to pull the 2 out. I have the 1/3, so that makes 2/3. And then I have square root of u du. Now I'm ready to change my limits. So my x limits are 1 and 2. So I plug in 1. 1 plus 1 gives me 2. I plug in 2. 2 cubed is 8. 8 plus 1 gives me 9. So my u limits are 9. Integrate here. So that's going to be u to the 3/2. It's going to be times 2/3 times the 2/3 that's already there. And we're going from 2 to 9. So I put these together. That gives me 4/9. I plug in the 9. Plug in the 2. And then I evaluate those. So I always wanted to try to do the bottom first. Remember, the bottom is always the root. You always want to try to do the root first if you can. In this case, I can do the square root of 9, which is 3, and then I cube 3, which gives me 27. On this one, I cannot do the square root of 2, so that means I want to do the power first, and then I'll come back and do the root. So 2 cubed is 8, and then I do the square root of 8. I can't clean this up by hand without a calculator, so I'm happy with that answer right there. Number 4 we did in class yesterday, so that's on the other video. Number 1 is also on the other video if you need to go back and look at that. Alright, so we're looking at number 5. Number 5, inside function is x squared plus 2. So that means my derivative would be du equals 2x dx. Again, I've got an x, I've got a dx. I do not have a 2, so that means this needs to be 1/2. And now I'm ready for my new integral. So the 1/2 is out there, and I have 1 over u cubed du. Now we're ready to integrate. Oh, I need my new limits. So, -2, I plug in -2. -2 squared is 4. 4 plus 2 gives me the 6. I plug in the -1. Negative 1 squared is 1. 1 plus 2 gives me 3. And as I was watching you guys yesterday, a lot of you did good. And you noticed that these two are out of order, so that means I need a negative out here, and I need to switch these. And I'll go ahead and change that to u to the negative 3 while I'm at it. Now we're ready to integrate. So that's going to be u to the negative 2, negative 1/2, and going from 3 to 6. So I put these together. That gives me 1/4. I move that back down. And then we're going from 3 to 6. So I plug in 6, which gives me that. I plug in 3, which gives me that. And at this point in the game, I'm pretty happy with this. If you looked on my answer sheet, I think that simplifies to negative 1 over 48 is what I got. But again, I'm happy when you get that far right there. Alright, so that's 5. Number 6. Inside on 6 is 2x plus 1. du is going to be 2 dx. I do not have a 2 over there, so that means I need to move this, which gives me that. So I have a 1/2 here. I have 1 over the square root of u du, and my limits over here are 0 to 4. So if I plug in 0, that gives me 1. I plug in 4, so that's 8. 8 plus 1 gives me 9. So same thing as u to the negative 1/2. So that turns into a positive 1/2 times 2 times the 1/2 that's there. We're going from 1 to 9. So those two cancel. I plug in. So 9 to the 1/2 minus 1 to the 1/2. So we end up with 3 minus 1 equals 2. So that's 6. Number 7. Number 7, inside is x cubed plus 1. du is 3x squared dx. I've got the x squared, but I do not have a 3. So I need the 1/3 over here. And we rewrite it. So I've got the 1/3. I've got the square root of u du. X limits are 0 and 1. Plug in 0. I get 1, plug in 1, I get 2. Ready to integrate? So this turns into u to the 3/2, so that means times 2/3 times the 1/3 that's already there, going from 1 to 2. Multiply this out, gives me 2/9, plug in 2, and plug in 1. Again, try to do the bottom first, which is the root. In this case, I can't do the square root of 2, so that means I'm going to do the top one first. 2 to the 3rd is 8. So I'm going to write this down as the square root of 8. On this one, 1 to any power is going to stay 1. And we're happy with that answer. All right, number 8. Inside is x squared plus 1. So that means du is 2x dx. So I've got the dx, I've got the x. So I need to move the 2. So 1/2 is out there. We have u to the 3rd. du, my limits are negative 1 and 1. So I stick negative 1 in here. That gives me 1 plus 1 is 2. I stick 1 in there. Also gives me 1 plus 1, which is 2. And a lot of you, I noticed this on Wednesday. When those two are the same, you remembered that our answer is 0, so that saves me some work on number 8. Number 9. Whoops, I haven't been doing that, have I? All right, inside, x plus 5. Derivative is 1 dx. Okay, so there's nothing going on here, so I can go ahead and put my u in there. So that's going to be the cube root of u du, but this is one of those cases where I have that extra x, so I need to come up here and solve for x. If we solve for x, we see that this is u minus 5, and then we need to work on our u limits. So -4 and 3, plug in -4, gives me 1, plug in 3, gives me 8. Okay, whenever I have something like this, hopefully you remember we need to separate this. So this is u to the first over this, make sure we subtract. So I have 1 minus 1/3, which gives me 2/3. And then minus 5, there's nothing to subtract with, so we just bring it to the top and make it negative. Now we're ready to integrate. Again, the trick, as we talked about yesterday, is just add these together. So that makes that 5/3, so we're going times 3/5. Minus 5 times, this makes this 2/3. Again, 3 plus a -1 gives me the 2, which means this is 3/2. We're going from 1 to 8, not 1 to 5. So 1 to 8. So I plug in 8. So 3/5. That would be 8 to the 5/3 minus, that's going to be 15 over 2. And that's going to be 8 to the 2/3. And then minus, I plug in 1, so when I plug in 1, it's just going to give me 1, so I know that's 3/5. And then minus 15 over 2. Because when I plug in 1 to both of these, whatever 1 to any power is always going to be 1. So I just know that that right side is going to be this. Again, try to do the root first. We can do the cube root of 8, which is 2. And then 2 to the 5th is 32. And then I need 32 times 3. So 32 times 3 is 96. Again, cube root of 8 is 2. 2 squared is 4. 4 times 15 is 60. 60 divided by 2 gives me 30. And then we'll just leave that alone. I'm happy at this point. You can leave your answer like this. I worked it out and I ended up with -39 over 10. But again, you get that far, I'm pretty pumped with that answer. All right, number 10 we did together in class yesterday, so go check that out if you weren't here or need a reminder. So number 11. All right, number 11, inside is 2x minus 1. And so my derivative is 2 dx. I have no 2 in the problem, so that means I need a 1/2. So I've got a 1/2 out here. I need a u down here. And then I have an extra x, so I need to come over here and figure out what x is. So if I add, that gives me u plus 1, and I divide, that ends up with u plus 1 divided by 2 du. My x limits are 1 to 5. I plug in 1. 2 times 1 is 2. 2 minus 1 gives me 1. Plug in 5. 5 times 2 is 10. 10 minus 1 gives me 9. Now I want to clean this up. So this thing over 2 is the same thing as multiplying by 1/2. So I need to factor that 1/2 out with the 1/2 that's already here. So that makes it 1/4. And then then we just have this over this, and we have this over that. The 2's gone when I factored it out and made it a 1/4. So I have a 1 over a 1/2, so 1 minus 1/2 gives me 1/2. And then I have a 1 over just the square root, so we make that a negative 1/2. Ready to integrate? So that's going to be 3/2, 2/3 plus 1/2 times 2, going from 1 to 9. All right. So plug in the 9. And then we know when we plug in the 1, that's just going to be 1, that's just going to be 1, so I have 2/3 plus 2. Alright, so 1/4. Again, do the root first if you can. Square root of 9 is 3. 3 cubed is 27. 27 times 2 is 54. Square root of 9 is 3. 3 times 2 gives me 6, and then I have minus 2/3 minus 2. I'm happy with that. If you clean it up, I ended up with 16/3 is my final answer on that one. All right, number 12. All right, number 12, inside is 2x over 3. So u equals 2x over 3. Some of us get hung up on taking the derivative of this. Remember, if it's 2x over 3, that's the same thing as 2/3 times x. So when I take the derivative of that, it's nothing more than just 2/3. So don't get hung up on that. If you see something like this, you might want to rewrite it as the way I rewrote it. All right. So there is no 2/3 in here, so I need to move that. So I need to multiply by the 3 and divide by the 2. So 3/2 du equals dx. So 3/2 is out here. I got cosine u in here, and then I need my u limits. So my x limits are 0 and pi over 2. I plug in 0, gives me 0. I plug in pi over 2, so that's going to be 2 times pi over 2 over 3. So the 2's cancel. I end up with pi over 3 there. All right. Integrate cosine, we get sine from 0 to pi over 3. So sine of pi over 3 minus sine of 0. We should know those. If you don't, you need to learn them. So sine of pi over 3 we should know is square root of 3 over 2, and sine of 0 we should know is 0. Multiply that together. We get 3 times the square root of 3 over 4. All right, 13. I really don't know why 13 is on this worksheet packet, because 13 does not involve a composite function, but we'll go ahead and work it. So we want to find the area bounded by that and the graph. So again, we know that area means definite integral. So definite integral, and we're talking about this interval, so we're going pi over 3, pi over 2, and we have x plus cosine x dx. Okay, not a composite function because we don't have anything inside of anything else, so in this problem we don't need a u. That's why I'm kind of wondering why it's on this worksheet. Alright, so if I integrate, that's x squared and 1/2. That's sine of x. We're going from pi over 3 to pi over 2. So I plug this in here, so that's going to be 1/2 times pi squared over 4 plus sine of pi over 2 minus, plug in the pi over 3, so that's going to be 1/2 times pi squared over 9, and then plus sine of pi over 3. So right here I get pi squared over 8. Right here, sine of pi over 2 we should know is 1. I get pi squared over 18, and sine of pi over 3 we should know square root of 3 over 2. I'm happy with that answer if that's what you give me. Alright, we did 14, 15, 16, 17, 18, 19 in class together yesterday. So that means we only have 20 and 21 left to work. Alright, on 20, using the substitution, u equals the square root of x. Okay, this is equal to which one of these following? Okay, so we know du is going to be 1 over 2 times the square root of x dx. Okay, so if I look at this, I see that there's not a 2 on the bottom, so that means I need to move the 2 over. Alright, so that means a 2 needs to be in front of my integral. So I can automatically get rid of d and e because I know that there has to be a 2 in front of my integral. I can probably also get rid of b because notice that the limits did not change. I need to change my limits. Alright, so we're looking at e to the u du. Now all that's left is to change my limits. So I just have to plug in here. So 1 and 4. If I plug 1 in here, square root of 1 is 1. And I plug 4 in here, square root of 4 is 2. So I want the one that matches this. There's my match, a 2, 1 to 2, e to the u du. So C is my match. Okay, this is an actual AP problem. They're just wanting to make sure you know how to handle u substitution. Pretty easy stuff, hopefully. Hopefully you agree. Alright, so let's look at 21. And we'll finish this video. 21, we want to solve that. Okay, remember, now that we have the fundamental theorem of calculus, we want to solve for y. Well, if I can write, let's write a y. Okay, and we're going to start with the y value they gave me. They gave me the y value of 3. The x value that goes with it is -1. Okay, and I don't have another x value to put in there, so we're going to put x in that place. Okay, so if they don't have another x value to give you, then we're going to put x in that place. I need to plug in. Alright, so then we're going to integrate our function. Now notice this has x in here, but we don't ever want this variable and the variable inside to match. So if we make this x, then we want to make the inside something else. So let's make it t. Okay, and if we make this t, then we got to make that dt. Alright. Now it's just a matter of solving it like we did on the rest of this assignment. So we have an inside function, which is 3t plus 5. Derivative of that is 3 dt. Okay? I don't have a 3 in here. You can think that there's a 3 in here if you want, but it's easier to think that there's not. Just put the 1/3 here. du equals dt. And then what we'll do is we'll pull this out as well as this and then reduce it. So I have the 3. I'm going to take the negative out and both of these numbers. So this is a negative 48 over 3. And then I stick u in here. I'm going to go ahead and move it to the top. It would be 1 over u cubed. I'm going to go ahead and move it to the top and make it u to the negative 3. Now all I have to do is change my limits. So here are my limits. And I need to plug them in here. So if I plug -1 in here, -3 plus 5 gives me 2. Then I plug x in here, so that's 3x plus 5. So my upper limit is 3x plus 5. Don't get scared that it's not a number or just a single variable. All right, then we integrate. I reduce this right here. That gives me 16. If I integrate this, that gives me u to the negative 2. So that means I need a negative 1/2 out here. And we're going from 2 to 3x plus 5. Okay, I'm going to go ahead and change this to that. And I'm going to go ahead and move this out. So the negatives cancel, and I divide by 2. So that ends up being plus 8. All right, plug in 3x plus 5. So 1 over 3x plus 5 squared, and then plug in 2. So minus 1/4. I'm pretty happy with this answer right here, but one more thing you could do is go ahead and distribute this 8 in there. So y equals 3 plus 8 over 3x plus 5 squared, and then 8 times that's going to give me minus 2, and then we can go ahead and put those two together and make this 1. Okay, there it is. Now, some of you may have just integrated this, did a plus c, and then plugged those points back in to find your c, and then plug your c back in and got the answer. That's fine. You should have got the same answer, but here's another method I wanted you to work. AP really likes for you to set it up this way. So if you can understand this, do it this way. If you can't, then go ahead and integrate, put the plus c in there, plug in your values to help you find c. Once you find c, then put c back in. You should get an answer very, very similar to this. All right, so there are the answers to Wednesday's assignment. We will shut this down, get it sent off, and I will record the answers to review for quiz 13.